So today we start with our overview of the construction materials, and we will start with the most primitive, one of the most basic materials we have used from ever. This is masonry. Right. In the photo, you have a Korean traditional wall. I took that photo in, I think, Bulgoksa last summer. This is a modern wall. It's just to cover the toilets in the back of the temple. So today's lecture is organized in the following way. We have a short, very short introduction about telling what is masonry or masonry. And then we go into the materials one by one, which is basically stone, natural material, brick. When I speak of brick, is bricks other than stone, so artificially made bricks. Then the bonding materials, this is the glue we use to put those bricks or stones together. Then a short comment on the assemblies, how we put things together. And as in most lectures, we will have a short comment on the sustainability issues related to that material. So we complement what we did last week. So today we went to the introduction and only stone. The rest we will see on Friday. You remember, because you studied, that we have like 2 building archetypes, earthwork and roof work. I will not elaborate on it. This is just a reminder. These are 6 words, 6 terms that you will hear all the time. And masonry applies mostly to the earthwork, stereotomy, or the massive construction. If you remember the sequence of architectural construction as it is explained in the textbook of Andrea de Places, which we recommended for this course, we start with the raw material. Well, we are studying stone, but I use timber because it's maybe the most complex material and one of the most beautiful we have. Then with that raw material, we have modules. It's already a step of elaboration which allows us to fabricate more sophisticated elements, which are the elements, right? Which is an assembly of those modules we had. In the case of timber, could be one window, for example, or one door. Then this is one of the confusing terms, and please be careful with this. What the book calls structures is what we call systems, right? Which is one part of the building which can be distinguished from the others. In this case of timber, we can consider, for example, partitions are a system within the building because it has many elements. It has walls, doors, so it's composed of many individual elements. And then finally, we have the structure, which we call the whole building, to avoid confusions with the structure, which also means the supporting skeleton or supporting elements. In Korean, it would be kujo, right? But it's not that kujo, it is the whole building, what the book refers as the full structure. So that said, let's go into the material itself. And in this lecture, we will study just the raw material and the basic modules, the basic parts. The assemblies we will see a little bit, as we said, next day. So this is a nice 12th century Romanesque building made of masonry, stone, and the lime mortar, which you see those buildings is slightly maintained, can last forever. So what is masonry, or masonry, as you like to pronounce? It is very simple. The most simple case is what you see in the photo, just piled material pieces to create a wall. And in the most basic example, without even any kind of bonding material, just the stones or the bricks one on top of the other. So which parts can we distinguish in masonry? Well, the first, very clearly, the pieces we put together, in this case, bricks. Then we have the pattern, interlocking, so the finished structure, the finished wall will be strong, right? Will be more difficult to break. And finally, the bonding material, the glue. In this case, it is cement mortar. Right? And you see, the key of the masonry is what you can do with your hands. Bricks usually one hand, stones with two hands. Actually, if you translate to Spanish, which is my my mother language, we call masonry mampostería, which means put in by hand, literally, right? Hand put construction. So let's go into the materials. And this is what we said. Today we will concentrate just on stone, natural material. In the photo, another example of masonry in which most of the pieces have no bonding material, but other areas they have. It's normal. Often you save bonding material is expensive and you will use it in corners, in more critical parts where you need more safety. So stone, how we divide this chapter. We will go very fast into the history on how this material has been used. In the case of stone, the history is very long, but the milestones are very clear, so not so many. Then the kinds of stone, this is something, given that this is a course of materials, you should be familiar. So you can distinguish more or less basic kinds of stones. We're not going to be very, very strict. So for construction architecture, we don't need to be very scientific. Geologists get very upset with us because we just mix many things, but okay, basic kinds of stone. Then important to be aware of the process and fabrication. Of course, they're not fabricated, but they are elaborated, right? We have to take from the mountains and there's a process until you have the stone you can put in your wall. We will see the modules, as we said. So the basic parts you can buy actually to use in your buildings to composite. So this is important because this will condition your decisions in terms of design. And we will start with the historical outline. So the most primitive we know about the stone is just the stones put on top of the other, and usually it is like a religious, funerary and ritual mounds and monuments, right? The easiest is to put a mound with some kind of fence around. This is an example taken from Mongolia. We call it dry masonry because it's not bonded, but any kind of mortar. It's just the stones put by gravity. Then we have the most amazing elements which history left us, the Neolithic monuments, which we think are religious. And they already express a technology quite sophisticated to raise those heavy stones. So it's quite expressive way of constructing. And we have examples since 12,000 years ago. That Neolithic refined actually the technique of construction. This is some mount you can find in Spain. This is again, we think it's religious. See the size of the stones. So there's a real exhibition of technology, and there is already quite decent interlocking to have this structure stable. Again, dry masonry, because in this case, gravity is enough to make this construction stable. And of course, if we go as near, let's say, as 4,000 years ago, we have one of the masterpieces, which is still amazing. Yes, Egypt pyramids, which is again stone over stone. More recent, so this is already after Christ, right? It's like much, much later. But still, pyramids have been like a very, very logic way of building monuments of stone. In this case, The construction is more modern, so they have a bonding material. It's not just a gravity construction. And probably in the 5th century before Christ, we have one of the peaks of architecture based on construction exclusively on stone. This is Greek. So this is Greek construction. Also, the photo is from a temple we have in Italy, Pestum, one of the masterpieces of the Doric. And well, Greeks refined so much the design and the detailing that even today we study those buildings, and 2,500 years all Europe and then America and sometimes Asia, when they want to be Western or Occidental in looking, refer to this origin. So you have one of the peaks of architecture of all times. Then Romans, already in our era, became more practical. So they did not make small temples as the Greek. They made huge public works. So in that case, they needed a huge amount of stone to make all these constructions. So they would make more economic brick, ceramic brick, done with clay, and use stone just for the outside finishings, what we call cladding. Cladding is applying a skin or applying a layer of a finished material. Of course, you have still structural elements which are important, but the mass is done with stone. And you will find very few of those monuments. You will find, if you go to Rome, for example, you'll see huge monuments and you see only the brick, because after the Christian era, or after Roman Empire collapsed, people would not bother to go to the quarries. They would go to the Roman monuments and take the marble to put in their buildings. As easy as that. Another peak came like 1,000 or 800 years later. Gothic construction, which was developed in northern Italy, Germany, France, and then it went to the south of Europe. The Gothic brought the structural possibilities of a stone to the limit, right? So even today, maintaining and even building this kind of construction would be almost unthinkable, would be prohibitive. So it is amazing even today to see what people could do with only stone and mortar in between. Renaissance, we're already speaking of 16th century, brought a return to the classicism, mostly to Rome, to those massive constructions. But interestingly, we have one unique example, El Escorial in Madrid, that was like let's say the headquarters of the whole Spanish Empire of the time. So this building had to be, well, minimalist was the concept of the king of the time, but it had to be eternal. Was a kind of a metaphor of eternity, of universe, as many centers of power. And the whole building was done on stone. Almost no timber was used, so it would be impervious or insensitive to fire, just kind of safety. And they also developed very refined techniques. I bring one example. This is the entrance to the church in the building, the cathedral they have inside. And to avoid using timber floors and to have this low ceiling they needed at that point, they were able to make a flat dome. So this is a very low spherical casket, right? Which has been cut, and we have only that flat part. So each stone is part of that spherical casket. You can imagine the knowledge of geometry those architects had to design those pieces one way and to match perfectly that shape. So the technology in that case, I think this is one also of the amazing elements of this building. And there's not much actually between Greek perfection, and the Gothic structural achievement, and then this refinement of the Renaissance. The use of the stone remained the same. But entering the 20th century with larger and more intensive construction, stone was not so advantageous. So we came back to the cladding, the Roman use of the stone just to apply to the outside. And this is a custom standard use of stone, which remains till today. So 100 years later, we do more or less the same. Only we use thinner and thinner pieces of stone. So we make buildings lighter and cheaper. Again, this post office in Vienna by Otto Wagner was interesting because he used those anchors, those metal anchors to support the stone as part of the design. So Wagner did not pretend to just fake a solid stone. He was very clear about this stone being a cladding. And this is starting of a modern mentality. You see, even in those buildings, people make graffiti. And we come to today. Well, this is quite a few years ago, but this is the usual cladding. Very thin stone, usually 2-3 centimeters, and fixed mechanically to some steel base. So you can see still the angles. So they have metal anchors, and it doesn't touch. So it's really one skin surrounding the real structure, the real building behind. But in recent years, we have architects trying to make new uses. And one of them is a Kengokuma, right? Quite popular, my Sombe in Tokyo University. And for example, he does a lot of research, of experiment with stones of a kind of a size which are light as brick. Right? So the construction is more light, more transparent, and the quality is not what we would expect from a stone construction. It's kind of going back to lightness. Of course, this needs a set of anchorings, and the construction very sophisticated. It's not easy to make just by putting mortar in between. Another example, just very thin stone elements hung with a wire mesh, a wire net, to make stone not just the skin applied as we see usually in buildings, but as a really light, almost like a textile. And you will hear often that this is step from stereotomy to tectonics. And this is where you have to be familiar with those words we commented at the beginning in the first lecture, because architects, critics, and historians use those terms all the time. So it's from massive construction to light, woven, interlocked elements. And of course, you know, gabion walls became very trendy in 1990s, late 90s. It's just stones inside of a steel grid box. So they are heavy, but since there's space between the stones, if you make it thin, you can have still some light going through. Of course, air can go through, and water, of course, filters, so you don't retain water. It's quite safe for retaining walls. So this makes also a very unusual feeling of a stone, and a very economic use of very massive stone walls. So we saw tradition and some innovation. So you see there are possibilities to use steel stone in different ways, as for example, Kengokuma did. I put just a small section on Korea because I think Korea, we are here, and the tradition is quite nice. So you have from just I don't know why, but it's kind of a spontaneous creation of a small ceremonial mounds. This is again bulguksa, to of course very sophisticated construction. Right? And I think it's fantastic. This masonry in bulguksa in Gyeongju, see a very rough, almost virgin stone, and then more organized, more classical elements with strong gargoyles to pour the water of rain so it doesn't damage. And then again, Korean classical orders with infill of, again, rough masonry. It's very, very expressive. I think it's very unique and nice, interesting. And of course, you have another interesting construction, which is very rough masonry bound or bond with clay, not mortar. So this clay just dissolves with the rain, and at some time has to be repaired. It's very easy to repair, but it is a very, very simple way of building and with almost zero impact in the environment. This is a modern construction, a modern reconstruction. So you see the tiles are using mortar, but again, we will see in later lectures that traditional construction also use just clay to bond the tiles when you need, not mortar. But you have a bit more geometrical mason. It is the outside wall of B1 in KUA, I think, or Myeongdong in Seoul. So we saw enough of history now. Now let's go into the core of the lecture, the kinds of stone. I will go faster because you don't need to memorize everything, just to see the main points and the main differences. So you are able to see at least the kind of stone we are using. Some stones are very easy to distinguish or are more tricky. Others are more tricky. And in the materials workshop we did when we had offline classes, we were able to understand much better than in the slides. But now that we are online, you have to rely on the photos, and we'll try to give more details later. And you have to look on yourselves and try to identify materials you see around. So if we go to the kinds of stone, there are like three big families. And this is something you studied probably in junior high school. Igneous, granite, basalt. This is which come from the magma just solidified, the magma of the volcanoes, you know, the inside of the earth, sort of molten stone. So when that solidifies, we have the igneous stone. Granite, basalt are very common materials, especially granite. You see in Korea, it's like the standard stone. Then we have sedimentary. Sandstone, limestone are the most common. There are more than those two. And it's just by sedimentation and pressure. So it's just the particles which glue together and make a stone which is less massive. And the metamorphic, which is a process of the sedimentary into a more compact stone. And then here we have the famous marble. This is maybe the most used. So quartzite is quite often used as slate and so on. So let's go into those three families one by one. But for any stone, once you look at it, you should be able to distinguish which kind of family it is, right? Of course, sedimentary to metamorphic is a process. So between purely sedimentary and totally metamorphic, you have stones which may be 50% of the process, maybe 70% of the process, or only 20% of the process, right, or 0%. So it's very hard to establish the limit between those two. We'll comment on it later. So general of igneous, as we said, solidification of earth magma. This is a huge family, right? And we are not distinguishing subfamilies. Just enough to say that. So because magma is fluid and becomes solid, those stones are very dense, are very strong because they are perfect in formation. They have hard superficial strength. That means it is hard to scratch, right? And they are most abundant because there is a lot of magma solidifying all the time under the earth, right? So this is the basic characteristics of those stones. Granite is probably the most typical. You don't need to memorize all, but you have to get the feeling. So this is a test stone, and I put this in black because 2.5 tons per cubic meter, or 2,500 kilograms per cubic meter, is like the average stone density, right? So if you see a stone, you say, okay, 2.5, bit less, bit more, you will have most stones. Then this is important just to have an idea of how strong they are. 1,000 kilograms per square centimeter of 100 megapascals is like 5 times the normal concrete. And even higher than many high-strength concrete. So this is a really strong stone which can support a huge amount of pressure. It is very hard, 6 to 7, you know, Mohs scale goes from 1 to 10. 10 is diamond. And usually 7 is quartz, which is already very strong. This is where they put usually the glasses of expensive watches and so on. They're very expensive, very hard to scratch. And granite is between 6 and 7. It has almost no porosity. And the composition is a quartz. This is why it's so strong. Feldspar and mica. Mica is what makes this kind of black points, right? And quartz is what makes this white background and this kind of glassy, right? So quartz is actually silica, right? Or silica dioxide. To be granite should be between 20 and 70%. Usually we consider the kinds, but don't worry about it. This is the scientific definition of granite. It is very clear aspect. It is very easy to distinguish. And if it has other materials, other minerals inside, it can have any kind of color, almost any color. But what makes the granite easy to distinguish is its texture, right? This grainy. This is what the name is called, granite. Okay, so you can find granite of almost any color. Careful, because very often these black are not really granite because they have less than the percentage of quartz, as I said. Sometimes this rainbow granite is actually metamorphic stone, which becomes the same as granite, but not by magma. But we don't worry, we're not geologists. And what we are interested is in the look and the characteristics of the stone. So in terms of mechanical density, aspect, and behavior is very similar. So I insist, geologists are not happy with the way we speak about stones, but for us, even if many are not granite, we call it granite, like a black granite or rainbow granite or so on. It has many uses. Since it's very strong, you will see very often in floors. This is pink granite with other stones. This is not granite. But very often in walls, a veneer, as a decoration, as a skin, as we said in the historical output. And it can be thicker and thinner. There's many ways to do it. You play with patterns and with textures. But also can be both structure and envelope. And we saw the Greek temples and so on, so you know very well. This is a very simple country house in Spain in which the stone is enough to make envelope and structure at the same time. Then pure structure, of course, envelope. This is a demonstration of how strong granite is. This is a building which has 7 floors on top of it, right? So always in the lower floor, this is Madrid. We put granite because it's safer and also stands better all the tensions of cars and the heats they can have. Of course, amazing how it is used for structure in Gothic cathedrals. Usually I put this as granite, but I think this should not be here because I think this is a different stone, but again. And even in granite is not very porous. This is a floor around Seoul. If you put water long enough, eventually it absorbs, right? And it can absorb also fat, so be careful with that. So especially the joints are the weak point. So it's not perfectly non-porous. So let's go to the next stone. Basalt is this black, more rough stone. This is a rock which goes to the surface and solidifies very fast. So it's not as crystallized, not as crystalline as granite. And even though you can polish it, it is rougher in look, right? It's like the typical Jeju stone. It is the densest, so it can go up to 3,200 kilograms per cubic meter. But again, you see the range is a bit over the dense, can be extremely strong. So almost twice as granite. It is less hard because it has less quartz. and can be porous because, as we said, this is very fast cooling, so it can have some porosity. And because it has very small silica, less than 20%, makes it less resistant to scratch, but also a bit porous. And usually it's gray to black, dark gray, light gray. So there's many varieties of basalt, of course, depends on how it solidifies. And you see this is a range on it. But still is the densest, hardest stone we have on Earth. And you see, depending on the quality and the quality, you can see some porosity, but this is misleading. That stone is really heavy and compact. And there are other stones which are really not basalt and are sold as basalt, but we don't worry about it, okay? And you can use it on walls and floors, and they have very unique, nice, natural look. So for igneous, only those two. Let's go to sedimentary, which is a very large group also. And as we said, this is just the bonding, the gluing together of sand particles, very thin or thicker. And actually, if you see the material, the texture is very sandy. Yeah, it looks like really, like you could scratch and have those particles going out. And this is like the opposite pole to the igneous. So they are the lightest, the weakest, the easiest to scratch, and that makes an advantage. So they are very easy to work, to make sculptures, to curve. So that's why they are very, very popular in some kind of architecture. And of course, the texture is quite warm, natural, so that look is also very appreciated. And that's a factor which makes designers to choose it very often. So one kind, which is the one we use, for example, sandstone. And it's like the stone which looks more closely to the sand, right? You see densities on the lower side. We have the reference of 2.5 or 2500. Just going to the lower side, but always this kind of a reference point. If you remember it, you can go to the heavier or to the lighter, and you know which kind of stone we are speaking about. You see the strength can change a lot depending on the stone. So very compact, very well compacted sandstone can be really, really strong, as strong as granite or basalt, but can be very weak. And that's the important thing for you to be aware. Natural materials have a big variation. So even with the same name, you can have very, very different materials. So when you need to use them for a specific purpose, you have to check very well those characteristics, right? It's really, really soft, 3 Mohs scale. We know that's 3 out of 10. It's very porous, 7% is a lot of absorption, so it's not a good idea to use them outside. Also, some people use them outside because this absorption makes the stone to age, to look old, and some people like it. And of course, depending on the sand, it has this kind of porous texture. And most often, the grains are silica or feldspar, which comes from the granite decomposition, right? Or disgregation. So if you go around to the Korean mountains, most of them around Seoul are granite. If you see those stones are attacked by the weather, so they start disgregating, and you see the sand which comes from that stone. That's really the sand you see later, gluing and making this kind of stones. And I try to have the best photos with the best quality, but well, there's many textures, so it can be almost any color. This is green, it's gray with quartz particles. Very appreciated. Many of those come from China, India, so we can find in Europe or in America, almost anywhere. But this kind of layering, which creates a very nice texture for interior decoration, golden. And this is an example of what I told you. Salamanca is a Spanish city which developed a very unique Renaissance style of facade decoration. And this was due to the easiness to curve this sandstone, right? And still we have monuments which have this kind of characteristic. Can be more classical, still the granite is used for the strong structural elements, but then all the decoration, more complicated, more simple, is used with sandstone, in this case, pinkish stone of the area. And this is a modern use. So this is a famous Asplund and Lawrence woodland crematorium in Stockholm, 1940. This photo was taken 2 years ago. And you see this is a very nice sandstone they have in Sweden. But after 80 years, in that case 78, I think, the water gets into the porous and the stone really changes color and becomes old, right? So if you don't mind the building becoming old in that sense, apparently Mr. Asplund and Lawrence thought that was nice image for a cemetery. That's okay, but you have to be aware of it. Yeah, it's not a bad choice, but you have to know that that stone will deteriorate faster than granite, for example. And you can see examples in Seoul. And again, you see them in facades. They get dirty very easily. They absorb all dirt, but they have this nice warm texture that people like. So that's your choice. And if you go around Seoul, you will see that very, very often. One more kind of stone, limestone. This is very white stone, and actually pure limestone is chalk. Actually, chalk is also a synonym of limestone. And it's the one we use to write in the old style blackboards. Density, as we see, is in the lower side. Since the prime material of limestone is not as dense as a silica, the stones never get so heavy as some sandstones, but still we are in the range, the lower side. Again, the compression is enormous and may change a lot. I will not repeat. Soft again and very absorbed. Well, it has a lot of water absorption. So in this case, it's even worse than in the case of a sandstone because the composition of material is calcium carbonate. This is the same as the sea shells and our bones. So very often this stone comes from organic deposits. The point is that this melts with carbon and all pollutants plus water, right? So to use those materials in outside facades, if it is pure limestone, it's very risky. Remember that we said that there is a kind of metamorphosis into marble. So when we see that in facades, probably there's like already 50% or 40% crystallized. So it's not a pure limestone. Right? So the pure limestone is like a really, you see the chalk you use for the whiteboard and the dust gets in your finger. So you would not use that to make a building. But if it has some process of crystallization, then probably it would stand the facade. And it's nice because it's a white color. Depending on the impurities, you will have a very trendy cream color. Cream actually comes from Spanish. Also, not always comes from Spain, but this is partly crystallized. So they sell it as a marble, but it's not marble or needs usually, right? So when it becomes marble, you will see it very clearly, but in the photos you cannot distinguish. But well, this could be maybe 60 to 80% crystallized. So you see the crystals, but still it's not pure marble. You see the fossil, as we said, calcium carbonate comes from those shells. So sometimes they start crystallizing and we have an in-between marble, but we call it limestones. And travertine is a variation of that limestone. And this is not a marble, right? So please do not confuse because travertine is very appreciated, can be a little bit crystallized. It is among less crystallized. Probably the serpentine, right, variety is a bit more crystallized, but still is not as strong as pure as marble itself. So don't get confused with this material. Yellow travertine, And the Triana is another stone, which is also from old fossil material. And this is an example of a normal whitish limestone used for a facade veneer, which in other parts has brick, right? And this is just a thin 20 or 25 millimeter stones just bonded to the border of the facade. All this is, you don't need to memorize, this is a local stone. So in every country, they put a second name to the stones based on the quarry, usually. So when you see granite whatever or limestone whatever, that whatever is usually the quarry where they pull out the stone. So we went through igneous and sedimentary. Let's go to the metamorphic, which are just in between, right? So sedimentary transfers into metamorphic, and metamorphic are closer to the igneous, but not always. So it's like the in-between kind. Well, this is the summary of what we saw before. So in general, as we said, sedimentary rocks with pressure, with temperature over millennia undergo a process of crystallization. And this is what happens with some of the igneous stones, right? And then the characteristics are in between the sedimentary and the igneous. Density is medium, resistance is medium, superficial strength is medium. And again, as they have this origin of sedimentary, they are easy to polish and slice. So they can be cut very easily and they are very easy to polish. This is why marble, pure marble is very, very brilliant. It can become as glass. So one very used material is slate. It's this kind of black, very easy to cut in thin layers. So the crystallization is layered. So you can have as little as 3-4 millimeters without breaking. Density, the middle range. Strength, in this case, we speak of flexion because those slates are used for roofs, are usually very thin. So for compression, there's no problem. Actually, any stone can resist anything. Jun Sung came to the class. So compression is still as good as the usual concrete. And this is easy to exfoliate. Exfoliate means to cut in very thin sheets, right? And can be cut and can be punched, so you can nail it without it breaking. And the absorption is not big, so this is why it is very used in roofs. Usually it's black, but you may have varieties of a green, gray, or brown, depending on the composition. And the origin is clay. Clay is the material we use for pottery, and the clay is very complex. So there's many varieties, and that clay, when it crystallizes, becomes many kinds of slate. And the main element of the slate is silica, right? So it's very used in roofing, very appreciated because it can adapt to almost any shape, and is very safe, very good waterproofing, and it has a nice stone finishing, so it's quite novel. You will see them very decorative in floors, also for walls, usually for rustic looking. Other material quite used and very conscious is quartzite. Of course, again, quartz is silica, right? So when it crystallizes, it becomes closer to real quartz. So this is what is called quartzite. And again, we are in the medium high. So quartzite is very well crystallized material. And if we have quartz, the density is very close to granite. You know, so granite was 20 to 70% quartz, right? So this is why they are very close. Compression is strong. Hardness, since main composition is quartz, is about 7, depending on how much crystallization it went. And depending on the degree of crystallization, the absorption is almost nothing to 4. And remember, full crystallized element goes very similar to the granite behavior. And the other materials, other minerals added to the rock, it changes the color. And you see one attractive point of quartzite is this kind of a chromatic variation, this color variation, which makes those kind of rustic garden or natural looking walls so attractive in many cases. So this very much crystallized quartzite. So this is what some raw quartzite stone without any kind of treatment. This is silver quartzite. Actually, it's not silver what it has, but it has some kind of metal which makes it polish, as if it has silver in it. This is Segovia again, as we said. This is the quarry quartzite. So it has iron. It's what is called ferrous. So that means iron inside, and makes it a reddish color. And this is an example of that silvery quartzite, which is used in walls as a decoration. This was the old coex before they went the renovation they did a few years ago. Marble is the most popular, right? And see, marble is this stone. Be careful with it because it's kind of language issue. So people call marble any polished stone, right? So be it a granite or limestone, whatever, if it is polished, it's marble, please don't do it. Marble is only this kind of stone. It is just a pure limestone crystallized, right? And depending on the minerals, again, the color may change. But this comes from limestone, calcium carbonate, as we said before. Then again, the density is on the high side, the strength as expected. Since the composition is calcium carbonate, not silica, still soft, harder than the limestone, but still soft. But since it is very well crystallized, it absorbs less water. And again, it's not as soft as sandstone, but still easy to sculpt. This is why marble is so popular with the sculptures. This is almost pure marble. Tassos comes from Turkey. Very expensive, very nice quality of the stone. This is Spanish, again, white Macael marble. This is again the quarry, which has very soft veneering or very soft pattern and very good quality. This is a bit more rough, but still very well crystallized, very good quality. Ibiza is the island where this stone comes. And then can be red or pink or brown. Emperador is quite popular in Korea and so on, right? And again, remember this is metamorphic stone, so many of those are in between limestone and marble, but they are more close to be 100% crystallized. So the quality varies a lot. And of course, that variation of colors can be used for interior decoration. In this case, I chose one classical example in Madrid. So we have 10 minutes left for half the lecture. Well, if we have no time, we can continue on Friday, but let's see as much as we can of stone today. So we saw very few kinds of stones. So, but I think they're the most usual, and I hope you got the point on what is common to all of them and what is the tips to distinguish them. How we get those stones from the mountain, from the quarry to our construction site. This is what is in the process of construction. So we start with the quarries. And quarries are huge, so humongous. This is the crane, and people we cannot even see, right? The small, this is the trucks. So quarries are huge, so you can see the road for the trucks to go to the construction site. So quarrying, as you can guess, means or is exploited by cutting like a cubes or prisms of a stone. You can see the marks. And this is like the initial module, module, but hardly we can use it. So even in the quarry, they have to break it in smaller pieces because they are almost impossible to manipulate. But all quarries will try to have chunks as big as possible, right, to reduce this process of breaking. You can see here the stairs to go to the different places of the quarry. So this is a detail. So the difficulty, you can guess by the pattern of the stone, the stone has to be cut. And very often use explosive, but explosive makes a lot of material be lost. So usually they will use cable cutting, which is kind of diamond cable. And in the cutting, they have to use water to reduce this dust. So you see, they drill the point where they want to cut the stone. And then in those drills, they put this cable, which is kind of diamond based saw, and with the machine, that saw will go through those holes, and it will end cutting the stone as it is a knife cutting cheese. So you see how it works. I have no idea of the noise it makes and the dust it produces, but the cut is very clean. Right. So you can see here, sometimes they use huge saws. Actually, after you have one full block, as we said, you try those blocks to be as big as possible, but once they fall, they cut again in smaller pieces, so they can be manipulated and transported. So once you have the big chunk and the blocks as large as possible, so you have the maximum possibilities of a processing element later, then they are put in a site that is possible to put into a truck, can be transported. So the limitation is the transport section. Here they classify by qualities, they see with imperfections, they mark them, they put a number, a series, and they bring them to the factory. So if you want to buy stone, depending on the quarries, this is the largest you may get. Remember, we saw the example of my Clever Hube, that kind of a building in Galicia, which is made of huge blocks. He used actually those raw blocks as they come from the quarry to make his building. Then in the factory, you have again slicing. As most of the uses are veneering, it is cut as they cut the bread in the bakery, right? And they have between, say, 20 to 40, 50 millimeters thickness, depending on the uses. And after that, they will do the finishing. Very often they polish, this stone polisher, or flaming. We will see the finishes later. We have just a few minutes. Right, so the finish can be just a raw saw cut, so just the marking of those saws we see that is sliced the stone. That's the raw stone. Can be honed. Honed is just before polishing, just taking the regularities, but still not being totally polished. It can be totally polished, like a mirror, and again, not all polished stone is marble. You can have marble which is not polished, and polished stone which is not marble, which is the most common. Sandblasted means just projecting sand. This is a hopper with a pressure line which blasts the sand into the stone, and that sand just removes the small impurities and gives this kind of sandy natural texture to the stone. Can be flamed. Flamed is most usually in Korea. You will see many stones on floors and facades flamed. That, as the name says, is done by fire. You apply fire to the surface of the stone, and then it removes the weaker parts. You have a rough texture, which looks very natural, but still has a very characteristic shape of those small thin chunks of stone, like peeled and left out. And as I tell you, if you look around, floors and walls often are flamed in Korea or around Seoul in the campus. And often it is done over a polished stone. So you will see remainings of the polished areas in not very well flamed stones around the campus. Tumbled age is a process in which they do not totally polish, so they make the stone look as if it was older than it is in reality. And then bush hammered is kind of hammer. So usually it's done by hand. In this case, it's by hand. You can see the pattern of the hits. But just in the factory, it's kind of rotational element. So if it's done by factory, you will see the circular patterns on the stone. Right? And again, it's very, very traditional and very favorite because it gives the stone a very, very natural texture. And then chiseled. Chisel is the tool of the sculptures and can be chiseled in many ways, like taking big chunks, making small patterns, or making lines or thinner lines, depending on the chisel you use. So chiseled is a full family of uses. And please, do not confuse chisel with a bush hammer. Right? So this is a different pattern than the slide we saw before. A broken edge, I don't know how to call it, but it's just the thin plates that get broken. And this broken edge is put to the outside to have this, again, this natural looking. So with one plate, you can pile many lines and you have this kind of texture. And sometimes it is done by using the stones which are broken during the fabrication. You get them very cheap and have still a very nice, very expressive wall. This is a table with a summary of the finishings. And well, you have etc. because this is just a summary. These are like the most common finishes we see in general. We have 2 minutes left for the modules. Actually, there's not much to say of the modules. We saw, as you can guess, in the quarry, the largest stone we can get is the one they put on the truck, on the quarry they can transport. And it depends on the stone and the quarry itself. So if you want to have those huge elements, you have to go to the quarry and buy just individual pieces by yourself. But as we saw, the stone goes to the factories and they prepare things we can use. And these are the modules. So in general, the modules are based on the size we can manipulate. And stones are so heavy that usually you have to manipulate by mechanical means. We don't need to, well, right. So the problem of the stone, and you know that even light stone is very heavy, but granite, which is in between, if we have one slab of very, very common size using the streets, it's already 50 kilograms. So if you see people putting slabs of stone on the street, you see those guys, you see they are making a big effort. So sometimes they use machines, and the many accelerated means, but that means that if you are working by hand, the limit of the size, or one of the limits is the weight, what people can handle. Those guys work 8 hours a day doing weightlifting, so we have to be conscious about it. And this is why this size 60 by 60 and up to 50 millimeters is one of the limits of the commercially made stone. You can see here, this was the renovation in Cheongno-gu, still going on. And you see you have 2 people, they have a different system, and you need 3 people to apply this stone. So you see that street stone is done over compacted sand. It's not over concrete. This is very good practice because it allows the rainwater to filter. If you remember our lecture for sustainability last Friday, you will know why I say that. So sizes, and we finish with this. This is one of the final slides. So give me just 2 more minutes. In general, the size is 600 by 600 millimeters, right? And the thickness is like 3, 2, or 5 centimeters, but 3 or 2 is the most common. In general, in Korea, depends on the countries and the quarries, but over 900 by 900 already overpriced. So when you go over this kind of 60 by 60, 60 by 40, 60 by 30, that module, things become very expensive and very hard to manipulate and to transport. So workability, as we said, is one of the points, right? Transportation, manipulation. So if we go to the largest size, we're already speaking of over 100 kilos, which not many people can manipulate. This is the usual thicknesses. So over 50, 100 millimeters are usually custom made. And the thickness depends also on the finishing. Of course, polished stone can be very thin, but a rough chisel stone needs more thickness, otherwise you may break it. And number 2, sorry about it, as we said, you can negotiate with the quarry You can have any size you want depending on the limitations you have. And to specify, this has to do with the last lecture, but it's important you're able, or you become used to specify stone not as a stone or natural stone. So at least when you explain the kind of stone you use in one project, you have to say the kind of stone and in detail. And if you can, specify the quarry and the quality, because the same quarry has different qualities of stone. The size, detail, and the finishing. This is the minimum 3 points you have to explain in any stone you use in any project. It's an example, very simple. Yellow granite from Shandong. This comes from China in standard quality, in pieces of 600, 400, 300, and flamed finished. So with this, we know which kind of stone we're going to use. And I annotated quality because quarries and countries have different ways of addressing the quality, but usually it's the first quality, standard quality, second quality, right? Standard quality, you have some irregularities. Remember, the stones are natural materials, they have variations. So just selling yellow granite from Shandong, you don't say the quality, you may get many surprises. So careful with the quality specification. So we'll speak about masonry on Friday. The assignment 2, sustainability, we explained last week. The submission link will open tomorrow, right? So please submit it for Friday. And assignment 1, I'm correcting. I will try to return before next class. So I think that's all I wanted to tell today. We are 4 minutes late. I will try to control the time, but it's getting better than last 2 weeks. So I hope you enjoyed the quiz and the lecture. Let me know if you have any difficulty or any opinion about it by email. And please say goodbye in the chat and remember to log out so I know you are not sleeping now. So see you Friday. Goodbye.